So hello, my name is Samantha Stott, and today I'm going to give you just a short presentation on assessing the spatial distribution of hawksbill turtles' nests in the South of Mahé, Seychelles, and I'll discuss quickly the potential of unmanned aerial vehicles that we can also call drones. So, as we may know, hawksbill turtles are under the IUCN Red List and are critically endangered, and therefore it's important to understand the nest site selection, as this understanding may allow us to reverse the downward trend that they are facing right now. Also, the nest site selection has important factors and consequences on the development and also the fitness of hatchlings. And as well, understanding these processes may allow us to reverse the downward trend. However, in the literature, it has been quite difficult to understand which factors affect what. And why did I choose drones? Because in recent years, there has been an increase in technology in drones. It has been more readily available, and also they have been used to get a better fine resolution spatial data, and have been used for management purposes across the globe. And so the aims of my study was, first of all, to assess what factors do affect the nest site selection of hawksbill turtles. Also, as I mentioned, assess the potential of the drones in predicting the likelihood of finding nests or not. Therefore, and also using the drone, creating a model, then try and define the ideal beach and the optimal beach, which is the highest number of nests, and find if it was a possibility using only drones. And therefore, with using all these targets, then it would allow me to have and provide to policymakers and other governmental bodies to try and understand if there were possibilities of putting conservation management strategies such as closing seasons, for example. So where did I focus my interest? It was on 6 main beaches. So why these 6? Because these are known to have a lot of nesting for hawksbill turtles. And the data was collected for ground data only from July 2016 to the 21st of June 2018. However, the drone data was only carried out in January 2019 to March 2019. And we collected a total of 691 nests across the 6 different beaches. So what kind of data did I get? Well, based on the number of nests, every time there was a nest, we had the type of vegetation, the percentage of vegetation in that area, the slope it was, the distance from the tide, which I also call zonation, and as you can see in the picture, the part where it's just open sand, which would be called zone A, and it had a bit of creepers, which are kind of little shrubs that go on the beach. Then we have the B zone, which is the main vegetation, and it's the shrub zone, and then Zone C, which is the furthest away, as you can see, it's mature trees only. The width was taken using drone images and satellite images, and not using ground data, as there were some issues. And the drone, to ensure that I had enough images to carry out my spatial analysis, I made sure I had 70% overlap on each image, so that then in my spatial analysis I could have something accurate. And basically it showed something. And this is the kind of image that you would get, which is called an orthomosaic image. And it collates each image based on its georeference location. In terms of analyses, I did a chi-square to just see if there was a preference in turtles, if they prefer to be in nests with vegetation, or if they prefer to be without vegetation at all. Then I conducted a generalized linear model, and this was to see what factors influence the nest site selection, such as the slope, such as the vegetation type, etc. Then I did a more in terms of data analysis for the spatial analysis, I did a semi-automatic classification, and this basically classifies the vegetation for you. And then a hotspot analysis was performed, and this was to understand or to locate where were the possible likelihoods of finding nests or not. In terms of our chi-squared, as you can see, there's a clear preference for having nests in vegetation. rather than without. So there is a relationship between the number of nests and the vegetation. And as you can see, we can start seeing that some beaches do have higher numbers of nests than others. And this is, I'll talk about later. The model showed that percentage canopy cover, percentage ground cover, and location were very significant in the nest site selection. And you may wonder why location was a variable included. It has been suggested in the literature that Hawksbill turtles go back to nest where they have previously hatched. So it was important to try and include this to see if this was true. In terms of vegetation, so on your right, you have the canopy vegetation, and that was dominated by coconut mainly, and Scaevola, which is quite a large shrub that has large leaves and provide a lot of shading, as coconut does. And in terms of ground vegetation, which is here, basically it was natural debris that dominated across the 6 sites. And you can see the one that has the lowest number of nests, which is Petite Police here. It has the highest variation in terms of canopy vegetation, and it also has a beach casuarina, which is an invasive species there, which looks like a pine, basically. And it's, as you may assume, it's very difficult to actually nest and burrow in an area which has very hard roots. In terms of the results of the spatial analysis, so the blue represents the low likelihood of finding a nest, and the red represents the highest likelihood of finding a nest. And as you may see, en Scaevola, I'll use this. Yes. En Scaevola here has the highest likelihood of finding nests. It also corresponds to what we have found during the ground vegetation and the modeling. It's that it has here a lot, the typical vegetation that you would find here is what we'll define later as the optimal vegetation. Also here, which has the lowest likelihood of, the model says has the lowest likelihood of finding a nest, which is also what we saw previously in the other graphs. So there is a clustering of nests based on our model. But I wanted to see how accurate this is. And so I overlapped it with the actual encountered nests that we had in the data. And we can see that there's an 87% overlap. So this means that we can, then afterwards, infer that there is an 87% confidence in the model that we have found. In terms of interpreting these results, so yes, overstory canopation and ground vegetation are significant, but why? So canopy could provide enough shading for the temperature sex determination of the eggs, so it would provide a temperature across the whole duration of the nest, so that the hatchling would have a higher success. It has been shown in the literature. Why ground vegetation is important? Because it also has roots, so Seychelles suffers from erosion and sand erosion, and this would provide a less mobile substrate. The results also suggest that there is a trade-off between how far the actual turtle will go to avoid predation and to be in an ideal area, and the effort it takes for her to go. So she will go generally in this vegetation zone and in zone B, as I've called it, and not in the open sand, which would be less effort, obviously, but not either in zone C, which would be very protected, but then obviously for the hatchlings, it would mean that they would be exposed to predation going back to the sea, and also it would mean more effort for them, and for the turtle obviously going back to the sea. In terms of, as I've shown in the GLM, that location did have a significant effect. So the hypothesis that turtles do go back to the nest that they previously hatched seemed to be accurate in our results, and so they do show this fidelity behavior. And also, we can see that drones have the capability to predict, combined with ground data at the moment, they do have the potential to locate potential nests. So what we can conclude is that the percentage ground vegetation, the canopy vegetation, the location are the main factors affecting nest site selection in the South of Mahé. We can also infer that, yes, drones are able to predict and find the likelihood of having a nest in a specific area, and they do have an accuracy of 87%. The ideal beach that was defined by the model said that it had to have a 10% natural debris, 50% coconut, canopy vegetation, or 30% Scaevola, 5% slope, degree of slope, and 18 meters width, which is basically exactly what is en Seychelles' characteristics of the beach, is basically the optimal beach, which is why we find the most number of nests. And it's also the furthest from Petite Police, which had the lowest number of nests, because that beach has a higher slope, which is about 7 degrees, and it also has a very short width. So the model does seem to be accurate. So that is the take-home message, is that drones do have the potential of accurately predicting the likelihood of finding nests. What's this? I would like to thank everyone at MCSS. I would also like to thank IMBRC for giving me the opportunity of carrying out my study there. And thank you for listening. And if you have any questions, please feel free.